Hi students, welcome to the chemistry sessions. So I have got a set of 10 questions for you, that too related to the chapter S block elements, right? CBSE pattern exercise. So I hope everybody has revised the chapter, especially the reasoning part, which is very important, right? So we will be discussing each one of the questions. I have got pattern questions for you, that means different marks it carries, right? So accordingly we have to answer. If it's a 1 mark question, we have to just maximum finish the question, finish the answer in 2 lines, right? Maximum of 2 lines, including any kind of an equation which is required over there, right? So let's move on to the very first question. What do we have? Yeah. So the first question, and question number 1 to 2 will be of 1 mark, right? Remember this. Always remember the weightage of the question and then only try to answer. Do not just go on and elaborate and just write the entire thing which you know, right? They are not testing that how much you know, they are testing that how precise the answer can be, how accurate you can be, right? As per the given marks. So what is the chemical formula of plaster of Paris? Give its 1 use. So what is the another name for plaster of Paris if I talk about in chemistry terms, in chemical terms? So it's a layman word basically, right? It is also known as plaster of Paris. So basically it is calcium. So it's pretty easy question. Calcium sulfate, hemihydrate, yes, and formed from gypsum, you know this. Now it is CaSO4 dot half H2O, clear? So that is what the plaster of Paris is, and they are asking give its 1 use. 1 use, you know, it can be used for building materials, it can be used in medical purpose, right? For medical purposes, just for immobilizing, if let's say I've got a fracture over here in my hand, so the plaster of Paris, there will be a covering, a mold which will be covering my entire hand so that it gets immobilized and the bone will get repaired, fine. So in all those cases these are used. I hope everybody is clear with it, and any one of the use you can write because they are just asking 1 use, right? As per the marks, 1 mark, half mark for the formula, half for the use, clear? Let's move on further. So what do we have in the next question? Yeah, why do we store sodium metal in kerosene oil and not in water? So you know this. Why it is stored in kerosene oil? In order to cut the supply of air and water, both. So what happens to the sodium metal basically whenever it tries to react with water? What will happen? Explosions. It will catch fire. Why? Due to the release of whenever sodium reacts with water, the main thing which is released is H2 plus the other ions Na plus and OH negative in the water. Due to the release of this hydrogen gas, we know it's explosive one, it immediately catches fire if it comes in contact with the water and in fact the air as well. That is why we cannot just openly put the sodium anywhere. We need something to cut out these supplies, and that is can be kerosene oil, can be wax, right, waxy substances, so that the entire wax or the oil, it surrounds the metal and it does not get in any contact with the water or air, right? So in chemical terms, it is, the main reason is due to the release of the hydrogen gas, and yes, in layman terms what we can call it, it is vigorous when it reacts with water or air, clear? Explosive or vigorous or violent reaction you can say. Fine, let's move on. Okay, what do we have in the next question? Question number 3 to 4, 2 marks. Arrange the following sulfates. Okay. Now, we have discussed about sulfates, carbonates, nitrates, we have discussed about hydroxides. So, these 4 are very important, fine. Any question can arise, can come up from this topic, right? So, what I have got here is something related to sulfates of alkaline earth metals. In the alkaline earth metals, we have discussed that in the order of decreasing thermal stability. Now, first of all, let me just write the sulfates over here. So, they already have given right. So, these are what? Alkaline earth metals, and if I try to have the sulfates of them, Now down the group what happens? Down the group the thermal stability will increase. You know, whenever we are going down the group, the solubility is decreasing. Why the solubility is decreasing? Because of decrease in the hydration enthalpy. The hydration enthalpy, whenever it gets dissolved in water, the energy which is released is not enough to overcome the forces of the lattice enthalpy, right? And that is why it does not get soluble down the group as much. Fine. So it's the solubility decreases down the group, sparingly soluble while coming down the group. Fine. And since the solubility, you can just remember it this way, that if the solubility is decreasing, that means it is not getting dissolved, right, in water. Thereby it will be a stable solid compound. Fine. And that is why these are thermally stable if we go down the group. So thereby thermal stability increases down the group. It's just the opposite. Fine. And what is the main reason behind this thermal stability increase? It's the more electropositive character. Fine. More the electropositive character, more it will be a very good. See here, these are all ionic compounds. Fine. And bigger the anion and bigger the cation, there will be a very good interaction between the two. So sulfate is itself a bigger one, and we get, let's say, barium, it's also a bigger one. So bigger and bigger will be a very good interaction in between. So due to this, they will be thermally stable. That means upon heating, they will not just like that dissociate. We will have to provide a lot of heat to dissociate them. Fine. Now what will be the decreasing order? Decreasing means starting from the very highest. I have got the highest is yeah, as per my series over here, I have got first is the strontium, then the calcium. This is the highest, second, third, and this is the least. Why? Beryllium is smaller size, sulfate is very bigger, so it will be again not a good kind of an interaction, right? It will be more of covalent as compared to the ionic character. Clear? So that completes my question number 3 as well. So I am not rubbing this off because this may be needed further. Now, which of the following has the highest solubility in each of the following? Fine. See here, we already have discussed in the case of sulfates, yes. So in the sulfates, Ba, barium, magnesium and calcium they have given. I need is the solubility as I am moving down the group, as I told you. Now the hydration enthalpy is not that much, right? I am not writing the exact reason for you, I am just telling you here. So listen carefully. So down the group always the solubility is going to decrease due to the decrease in the hydration enthalpy, decrease in hydration enthalpy. So basically what is happening is down the group lattice enthalpy as well as hydration enthalpy both are decreasing together. But the decrease in the hydration enthalpy is much more, thereby accounting for the fact that it is very less soluble in water. Clear? So what do I have here? Highest solubility out of the 3 I need to find out. So it's definitely the barium. This one first, right? Second one would be this, and third will be the least. Now if I talk about the solubility in the case of hydroxides, it's somewhat different. This is important. And this I have already told you in my session that in case of hydroxides, the order is opposite. In case of hydroxides, the solubility increases down the group, right? Because now these compounds, if I move down the group, see here, down the group will be barium hydroxide basically. So it's a bigger one, right? So we are not considering here which one is bigger, which one is not. So basically this atom, this compound will get easily dissociated in water, right? It, due to the bigger size, it will get dissolved in the water very easily, thereby giving more and more OH negative ions. So basically down the group the basicity is increasing. Down the group basicity is increasing, and due to the increase in this basicity, solubility is in turn increasing. Fine. So which one will be having the highest? The highest, yeah. First of all, let me just, okay, move on to the first part over here. Have we done that correct or not? Which one is having the highest solubility? So I think I have written just the opposite of it, because here I have told you that down the group the solubility is decreasing. So the least would be for the barium, right? That means magnesium should be having the highest one, right? We just have discussed, I just have written mistakenly the opposite order. So it will be 1, then 2 and then 3. This one will be having the highest, fine. And here the order will be just the opposite. So always remember, in case of hydroxides, the order is just the opposite, which is barium must be having the highest solubility because it can give OH negative ions very easily, more basic. So 1, then 2 and then 3. Clear? So I hope everybody is clear with the fact. Now let's move on to the question number 5. Right, okay, let's just remove this. Now, how do the following properties vary among the alkali metals? So it's a simple question, just the general idea we have to give. They are asking about alkali metals. What are alkali metals? Group 1. So it is Leena ki Rab se friendship, yes? Lithium, sodium, potassium, rubidium, cesium and francium, fine. Atomic radius. Now, how do you account for this atomic radii? Atomic radii, since it is the group 1, the very first series, fine. So it will be having the highest atomic radii first of all, highest in period, fine. These are having highest atomic radii in period. If I move down the group, what will happen? Again, due to the increase in the atomic number, there should be more of nuclear charge and there should be a decrease if I go down the group. Whereas, due to the addition of more and more shells and due to those adding shells, what will happen is, there is shielding effect going on, yes. Due to the inner shells, there is more shielding effect. Fine, and due to that shielding effect, the size is thereby increasing down the group, right? Counteracting with that of the increasing nuclear charge, we have got a shielding effect in between, and due to which the size is in turn increasing instead of decreasing down the group, fine. So here, atomic radius or radii increases down the group. Here they were small, now this, like that, it is increasing, fine. And that is how the atomic radii is increasing, and they have got the biggest if we talk about the entire period. Clear? Done. Ionization energy. Ionization energy again based on the atomic radii, right? So down the group, ionization energy, it is decreasing because more of the size, it will give away the electron, the free electron, that is only 1, right? So lithium has got configuration 1s2, 2s1, yes, and similar will be only 1 electron is there to lose, right, to attain the stable noble gas configuration. Down the group, ionization energy decreases because of the bigger size, it is willingly able to give the electron. If I talk about in the period, so since it's having the biggest size, it will be having the most metallic character, it will be more electropositive, and yeah, that completes my third point as well. And ionization energy, if I talk about the period, group 1 elements have got the least ionization enthalpy, least ionization energy, least in period because of the biggest size. Clear? So I have not discussed that in a detail because we already have done that. Just remember the tricks over here, the exact reasons should be there, right? So that you are able to, again, what has just come up in my mind is, some of the students, what they do is, if they are getting confused in any one of these reasons, right, so they tend to, you know, write the entire answer in more lines, right. They just form a paragraph for it and they think that, yeah, while writing this much of amount, they will get marks. But it is not like that. Teacher always accepts what very precise answer, that yes, you know that what ionization concept is, right. That means ionization energy in the period, they have got the least, right. This much line will do your work. You are not supposed to write the entire paragraph for it. If you are getting confused, just leave it for some time, then rethink over it, right. But don't just go and try to irritate the teacher, right. If the teacher gets irritated, it will be fatal for you, because in the upcoming answers also, he or she may tend to deduct your marks unnecessarily, right. So, next, question number 6, contrast the action of the heat on the following and explain your answer. Important one, right. So, what do we have to do is, we need to heat all of these compounds up, right, these two pairs, these two pairs, these two pairs, fine. And via the heating action, we have to just distinguish that how this particular compound is acting and how the other particular compound is acting towards the heat, right. What is the kind of a difference in between? So, first is, okay, let me just write, since these are alkali metals and alkaline earth metals, so let me just write the elements over here. And that's it, fine. So, in the first one, what do I have is Na2CO3 and CaCO3, fine. Now see, Na belongs to group 1, Ca belongs to group number 2, fine. Whenever I am trying to give them heat, so which one of you think that will be very stable towards heat? See here, Na is sort of smaller in size as compared to the calcium, fine. So, what will be happening is, Na will not dissociate that comfortably as compared to the calcium carbonate. In calcium carbonate, if we heat it up, it easily gets converted into calcium oxide, that is a quicklime, plus carbon dioxide, that is an easy preparation for the quicklime as well, fine. But whereas in this case, what happens, it faces some difficulty while dissociating while we are giving the heat, fine. So, here what happens is, this is anhydrous that we obtain, anhydrous thing. But over here, again we get is oxide, very well, we get oxide, but there will be a slight difficulty in obtaining this due to the smaller size of the sodium over here, fine. Clear about the fact? Okay, if I see via the diagonal relationship, the sizes are sort of comparable also. But again what I am saying is, we have got difficulty over here in dissociation somewhat, whereas in this case, it is not that much difficult, fine. And yes, carbon dioxide is released in both of them, fine. And you have to keep in mind the valencies, so that you properly write the oxides over here, fine. In the next one, MgCl2.6H2, so basically we have got hydrates over here for the magnesium and for the calcium. So, it is MgCl2.6H2 and CaCl2.6H2, fine. What will be happening? See, if I heat it up, it loses 4 water molecules first, and then we get completely anhydrous calcium chloride, anhydrous, fine. Whereas in this case, again, due to the smaller size of magnesium, what happens is, it poses, it faces a little difficulty in first of all losing 4 water molecules, but it does form this dihydrate. It does form dihydrate, but what happens is, on further heating, it not just, go into the anhydrous state straight away, but what it forms is MgOHCl, right? It is a kind of an intermediate which is formed in between. You may not find this particular reaction in your books, but yes, again, as the question says, we have to, just strike out some of the differences between the two. So, we are doing that. So, not just straight away going into the anhydrous state, there is kind of an intermediate which is formed here, and yes, after further heating, then it tends to get converted into anhydrous magnesium chloride. Clear? Done? Next one. So, it is a simple one, calcium nitrate and sodium nitrate. Calcium and sodium, again the comparison. So, it is calcium nitrate and NaNO3. So, basically what happens when we heat it up? Here, calcium nitrate gets converted into calcium oxide plus NO2 plus what I am left with here? O2. Fine. Whereas, if I try to heat this nitrate, we get is nitrite in this case, NaNO2, along with what? O2. Fine. So, that is what the differences in between the two are. Clear? And both are belonging to two different groups, two different kind of properties they have, right? And two different kind of behaviors they have. Clear about the fact? So, yeah, this one is really important. Mark this as important. Out of the three, this one is more important. Clear? So, I hope everybody is through with question number 6 as well. So, let us move on further to the question number 7. What happens when? Now, although it was a 3-mark question, so you can just answer any 3, but we will be discussing all the 4, right? So, what happens when calcium nitrate is heated? We already have done that. We get CaO plus NO2 plus O2 as the products. Chlorine reacts with slaked lime. You know what reaction is this? So, we get a very, very important compound which is of our use, right? See here, it's slaked lime is calcium hydroxide. If I am trying to react it with the Cl2, we get is CaCl2 plus CaOCl2, right? This. And what is this? What mixture is this? Tell me. So, this is what? Bleaching powder. Yes, we have formed the bleaching powder. And this is calcium hypochlorite, right? So, this is this hypochlorite. This one, calcium hypochlorite. Clear? I hope that is clear to you. Okay, now, done. Quicklime is heated with silica. What do you get? CaO plus SiO2. It's a simple reaction, CaSiO3 we get. Calcium silicate. Clear? Magnesium is burned in air. It's a kind of a typical reaction. You must be, thinking that it's very easy. No, it is not. What you have to consider is, always remember, whenever they are talking about air, always consider two reactions, O2 and N2, right? And yes, magnesium burns with a dazzling flame. One we get is magnesium oxide and one we get is magnesium nitrite. You can form the formulas very well. I am not going into the detail of that. We have done this ample amount of times, right? So, 7th question, done. Let's move to question number 8. How would you explain? Now, this question has been picked up straight away from the NCERT. I wanted to discuss this because again some of the students face difficulty in answering such questions, right? This type of reasoning questions. BeO is insoluble but BeSO4 is soluble in water, right? So, first of all, what should be your approach? BeO, all of a sudden some compound comes up, right? They are telling that it's soluble, the other is not, right? How can you just, out of all the reasons, what reason you can apply so that you get the exact answer, exact right answer? See here, first of all, we are checking the solubility in water, clear? and what I've got is BeSO4, BeO. First of all, what is the first step you need to do? First step is study the size of ions, size and type of ions. Fine. If comparable sizes, then it is a good ionic compound. Yes. Or apply Fajan's rule. If you are applying Fajan's rule, then it will account for the covalent character. Find out the covalent character, right? So, see here, BeO is insoluble but BeSO4 is soluble. What they have written is try to mold your answer in that way, right? It is a trick. Insolubility. Why there should be an insolubility for BeO? Study the ion. Be is small, O is small. Fine. Comparable sizes. Fine. Insoluble in water. But if I talk about BeSO4, Be smaller size, SO4 bigger. See here, Be smaller, SO4 bigger. What will happen? This is an ionic compound. Yes, this is an ionic compound, right? Okay, just wait. Yeah, just correct it over here whenever they have got the comparable sizes. That means, yeah, it's a, yeah, good or I can say more lattice energy. Fine. Now it will come up. See here. BeO comparable sizes, beryllium small, oxygen small, comparable sizes. They can bond very good, right? In a very good manner. So what will happen? There will be high strength and more lattice energy will be there, right? And due to this stuff, what will happen? There will be insolubility, right? Insolubility. If I talk about BeSO4, now this compound will be ionic because smaller size of beryllium, sulfate is bigger. Fine. Now this will be very much soluble in water because it can dissociate into ions. It's not bonding that perfectly. Fine. If I talk about the second one, BeO is soluble but BeSO4 is insoluble in water. Now Ba is bigger in size. If I am going down the group, it is a very big atom, right? Ba is big, O is small, soluble in water, incomparable sizes, solubility will be there. BaSO4, bigger Ba and bigger sulfate, insoluble in water. Why? Because now the sizes will be comparable, very good strength between the two, very good lattice energy, high lattice energy, right? Now are you able to correlate this? If the sizes are incomparable, right, it accounts for solubility. If the sizes are comparable, it accounts for insolubility. All in all, you have got it. Now LiI is more soluble than Ki in ethanol. First of all, they are checking the solubility not in water but in ethanol. Fine. So what do you have to do in this case? See here, if they are checking the solubility in ethanol, that means ethanol is an organic solvent. Yes. Organic solvent usually dissolves covalent compounds, and from this thing, I have just found out that I have to apply Fajan's rule over here. See, Fajan's rule. LiI, what does Fajan's rule says? Smaller the positive ion, bigger the anion, what will happen? More will be the polarization, more covalency. Yes, thereby if the compound is more covalent, it's sort of non-polar, right? And if it's non-polar sort of, then it is very well able to get dissolved in the organic compound, right? Organic solvent. So that means LiI is more soluble because it is more covalent, yes, as per the Fajan's rule. as compared to the Ki in ethanol. Clear? Clear about the fact? And also in the previous two cases, if you still don't get it, if you are getting still confused, what you have to do is, you can just apply the concept of hydration energy as well, right? Depending upon the sizes that we have judged, you can just try out the concept of lattice energy and hydration enthalpy, which always go hand in hand, you know that, right? So I hope everybody has got it. Now, question number 8 done. Question number 9th. Okay. Describe in detail the manufacture of sodium carbonate by Solvay process. As I told you, the Solvay process is the important one, right? So I have to prepare sodium carbonate. Can you do that? So I'll be just writing down very little points about it, right? Not the entire thing, because we already have discussed this very process in a detail, right? So Solvay process, what is the main thing by which it goes? The main thing is NaHCO3, right? It's low solubility. You know, you remember this? And due to its low solubility, it's obtained as a PPT and then it gets converted. Whenever we heat this, it gets converted to Na2CO3 that we need. Yes? So what do we take here in Solvay process is brine solution. What is this brine solution? I am adding NaCl solution, right? Saturated with ammonia, saturated with NH3, right? And what do we gonna do with this particular solution is we pass CO2 through it, more and more CO2 till we obtain this, right? And finally, we get our NaHCO3, which is insoluble in water. We can obtain it, right? And yeah, these are some of the very key points which I have got. Ammonia, I need to prepare the solution, ammoniated solution, passing CO2 through it. We get is ammonium carbonate. Once I get this ammonium carbonate, I need to convert this ammonium carbonate into ammonium hydrogen carbonate. Again, I am passing more and more CO2, NH4, HCO3. Now, once I get this, what will happen now? I need to add NaCl, and yes, we get is NH4Cl plus NaHCO3 that I needed, and finally Na2CO3. Clear? Yeah, that is Solvay's process, and yes, you need to form the entire answer. I am not going to do it for you. We have just revised the concept here. And yes, the thing that I told you, that why the carbon dioxide is added and what is the role of the carbon dioxide, that also you can mention over here. That will be a plus point for you, right? That formation of carbonic acid and all that stuff, right? Now let's move on to the 10th question. Again a 5-mark question. It's the diagonal relationship. We know what the diagonal relationship is. This is what the diagonal relationship is. So why there is diagonal relationship, right? What is the diagonal relationship? It's the properties of these elements are which are diagonally arranged, are interrelated, right? The properties are somewhat similar. First is this diagonal relationship definition. The cause is the somewhat comparable sizes. You can very well tell them. Fine. Discuss any 5 points showing the diagonal. Any 5 you can write, but that too relevant. Don't just go on with the theory points. Just write some of the points involving the reactions. That will actually fetch you marks. So first what you can write is, yeah, you will have to write that both are small in size, yes, hard, lighter elements of the entire group, fine, having high ionization enthalpy. So don't just separate these points. First of all, you can just write this thing in only one point because each one of it is interrelated. Next, what you can write is about that both of them forms the monoxide, yes. The second third what you can write is that both directly react with the nitrogen. Nitride formation, yes. What are the nitrides formed? So it's Li3 N2, nitride is 2 negative, Li is plus 1, yeah, so it will be Li3N, Mg3N2 for the magnesium, right? Third point. Fourth, what you can write? Both of them are deliquescent, yes. Both of them are deliquescent, and yes, both of them form hydrates. Yes, you can very well write the hydrates. What else you can write? Yeah, for the lithium and the magnesium, yeah, you can write about the carbonates, that they get disintegrated, they get decomposed while heating up, right? That can be another point. And yes, these are some of the very important points that I have discussed over here. I hope that is clear to you. So, decomposition of carbonates of them you can write. Fine. What else you can write is LiCl you have got, MgCl2 you have got. Fine. Again, these can be existing as hydrates. Fine. You can very well form the hydrates of them, the point that I have just told you. Fine. Clear about it? And yeah, some other points that we have discussed in detail in the session itself, you can write any one of them. But always remember that just try to write the reactions in that, so that you get more and more marks. Clear? So I hope everybody has understood the 10th question also. Go in a stepwise manner, that here first of all the definition of the diagonal relationship, second the cause, and the 5 points that you need to write. Clear? So I hope everybody has enjoyed this questionnaire round, and yes, again we have done a lot of reasoning here. Just try to revise it once again, and that is it, right? That will give you good marks, and along with what you can do is just try to make a note of it, right? Make simple notes of these reasoning questions that we have done, so that you are able to revise those again at the time of exam. Clear? Have a nice day.